Hello friends, in this video we're going to solve these questions. This question was requested by one of my subscriber. Okay, so before we start, please subscribe the channel, hit the thumbs up button, also share with your friends. It's for me to create new contents for you and help me to grow my channel. Okay, so now you see, when you see this kind of questions, this is partial derivative. Okay, so here you see, remember one more thing, here we have variables x and y, and this z should be taken as a function of x and y. Okay, that should be considered as function of x and y. That's why we able to differentiate this z with respect to x as well as y. Okay, otherwise that's going to be equal to 0. Okay, so now let's start. Let me go to a new slide and let me take this question. So here you see, this is what given in the question. Let me take this is equation number 1 and we are to solve this too. Okay, so now you see, first in order to obtain this, let me differentiate equation number 1 with respect to x. Okay, differentiating equation number 1 with respect to x. Okay, if you differentiate with respect to x, now you see z cube, z is function of both x and y. When you differentiate z with respect to x, then it's gonna be 3z square, but it is function of both x and y. This is not only a function of x, that's why we have to multiply it del z by del x, right? So hope you know these things. So 3z square del z by del x, then minus. So when you differentiate this with respect to x, and then y should be taken as constant. So 3y, and z is a function of both x and y, so that's why del z by del x, minus, and if you differentiate this with respect to x, that's going to be 3 only is equal to 0. So now if you cancel, if you divide each term by 3, then 3 is going to be cancelled. 0 divided by 3 remains 0. So hope you have understood this. So from these two terms you can take del z by del x common, then within bracket what we're going to have, z square minus y del z by del x is taken common is equal to, here it should be 1. Okay, when you divide 3 by 3, then that's going to be 1, so minus 1 on the other side, that's going to be plus 1. Okay, so del z by del x, that's going to be equal to 1 by z square minus y. So let me take this as equation number 2. Now in order to obtain this, let us differentiate equation number 1 with respect to y. Okay, differentiating equation number 1 with respect to y. So again we're gonna proceed same way. When you differentiate z cube, that's gonna give you 3z square, and z is function of both x and y. It is not only a function of x or not a function of only y, so that's why here we need to multiply del z by del y when you differentiate with respect to y, then minus. So here you see, next term minus 3yz, this is a function of y and this is function of both x and y, so here we're going to take 3y as u and z as v. So we're going to use the product rule, and if you do so, first function derivative of the second function del z by del y, then second function derivative of the first function. Here derivative of first function is 3y, derivative of 3y is 3 only, and second function is del z by del y, sorry, only z. Derivative of first function, derivative of 3y is simply 3, and then we need to write the second function. What was the second function? Z, right? So here we have used the product rule. Then this x term containing x only, that should be taken as constant, so that's why it is 0. So now if you remove the bracket, if you remove this bracket, this minus is going to be plus, so we can write directly this way. So let me remove this bracket, then this minus symbol going to be this positive going to be minus negative. So here let us take del z by del y common, then and one more thing, you can divide each term by 3, so 3 cancels. So here you're going to get z square minus y del z by del y, and you can transfer this z to other side, that's going to be plus z. Okay, So that's why it implies del z by del y is equal to z by z square minus y. Okay, so now let us take this is equation number 3. This is equation number 3. Now you see, if you observe this equation number 2 and equation number 3 carefully, if you multiply z with equation number 2, then you're gonna get the right hand side, because if you multiply z here and here, that's gonna be the left hand side, not right hand side. And then this left hand side is gonna be the left hand side of this equation, which one we need to prove, and this part gonna be equal to this del z by del y from equation number 3 if you compare this. So just let me write here, just wait. Okay, so what we're going to do here now, so let me split the screen. So what we're going to do, equation number 2 into z, multiplying both sides by z of equation number 2, then you're going to get z into del z by del x is equal to z into z square minus y. So here I have multiplied z, and not only here also we have multiplied z. Okay, so now you see this has become the right hand side of this equation number 3. This becomes right hand side of equation number 3. So that's why from equation number 3 what we're gonna get, del z by del x. So we can replace this by del y by del z by del y, del z by del y. This is the first thing we need to prove. Okay, so this is proved. So first one is proved, number 1 is proved. So let me take this as equation number 4, because we don't know, maybe we need to use this in order to prove this equation. So in order to prove this second part of this question, let me copy this equation number 4 and let me go to the next slide. Okay, so here is the equation number 4 and this is what we need to prove. Okay, so now let us differentiate equation number 4 with respect to y. Differentiating equation number 4 with respect to y. If you differentiate equation number 4 with respect to y, you have to consider z into del z by del x as u into v. Okay, so then if you differentiate it with respect to y, then what you're gonna get, first function that is z, and derivative of the second function del y of del z by del x, right? Then plus second function that is del z by del x, derivative of the first function that is z, derivative of z with respect to y, del z by del y. That's what we're going to get on the left hand side. And on the right hand side, if you differentiate with respect to y, it is already del z by del y. If you differentiate it with respect to y, then what you're going to get here, so this first term becomes del z, second order derivative, partial derivative of z with respect to x and y, so it's going to be del x del y plus del z by del x del z by del y. Then the right hand side becomes del 2z by del x, del y 2. That's what we're gonna get. Now you see, so what we can do here, and here this del z by del y from equation number 4, this del z by del y, we can replace this by this one, z into del z by del x, right? We can replace it by this. Okay, so if you do so, then what you're gonna get, so z del x del y, del to z by del x del y plus here del z by del x, this term is replaced by z into del z by del x is equal to del to z by del y2. So here we have used equation number 4 again, using equation number 4. So now if you multiply this two, then it's gonna be you can write this term this way, square, right? You can write that way. That's what we have done. Okay, so now you see, from these two terms you can take z common. Okay, if you take z common, then what you're gonna have, then just wait, let me rearrange these things. So in order to obtain maximum space to solve this question in the single slide. Okay, now the next step, what we're gonna do, we're gonna take the z common. Okay, z is taken common within bracket. What we have got, del to z by del x by del y, del x by del y, sorry, del to z by del x del y, plus del z by del x whole square. On the right hand side we have got second order derivative, partial derivative of z with respect to y, right? So this is what we needed to prove. So let me write this one again, just wait, let me write it properly. Let me write here, enough space is there, just wait, just give me a second. So let me write the last step here. This is here, we can write. Okay, so this is the number 2 we needed to prove. This is proof. So hope you have understood this. Number 2 is proved. So thank you for watching. See you in the next video.